In this lecture, we are going to be looking in more detail at Ethereum. The first thing we are going to examine is the Ethereum blockchain. The Ethereum app doesn't require one entity to store and control its data. To accomplish this, Ethereum borrows heavily from Bitcoin's protocol and its blockchain design, but tweaks it to support applications beyond money. Ethereum aims to abstract away Bitcoin's design, however, so that developers can create more bespoke applications or agreements. The structure of the Ethereum blockchain is very similar to Bitcoin's, in that it is a shared record of the entire transaction history. Every node on the network stores a copy of this history. The big difference with Ethereum is that its nodes store the most recent state of each smart contract, in addition to all of the Ether transactions. For each Ethereum application, the network needs to keep track of the state, or the current information of all of these applications, including each user's balance, all the smart contract code and where it's all stored. Bitcoin uses unspent transaction outputs to track who has how much Bitcoin. While it sounds more complex, the idea is fairly simple. Every time a Bitcoin transaction is made, the network breaks the total amount as if it was paper money, issuing back Bitcoins in a way that makes the data behave similarly to physical coins or change. To make future transactions, the Bitcoin network must add up all your pieces of change, which are classed as either spent or unspent. Ethereum, on the other hand, uses accounts. Like bank account funds, Ether tokens appear in a wallet, and can be ported, so to speak, to another account. Funds are always somewhere, yet don't have what you might call a continued relationship. With Ethereum, every time a program is used, a network of thousands of computers processes it. Remember that every node in the network holds a copy of the transaction and smart contract history of the network, in addition to keeping track of the current state. Every time a user performs some action, all of the nodes on the network need to come to the agreement that this change took place. The goal here is for the network of miners and nodes to take responsibility for transferring the shift from state to state, rather than some authority such as PayPal or a bank. Bitcoin miners validate the shift of ownership of Bitcoins from one person to another. The EVM or Ethereum virtual machine executes a contract with whatever rules the developer initially programmed. Miners are preventing bad behavior, like ensuring that no one is spending their money more than once and rejecting smart contracts that haven't been paid for. There are a few thousand Ethereum nodes out there, and every node is compiling and executing the same code. But, you might be thinking, isn't that much more expensive than a normal computation? Yes, it is. That's why the network might only be used for particular use cases.